Hey everyone, today I'm going to teach you how to do logarithm and exponential equations. So to get you started, I want to show you something that you are familiar with, and that would be just solving an equation. So if I had 4x plus 7 equals 10 and told you to solve for x, the first thing you would do is minus 7, because if I have a plus 7, if I subtract 7, I will get 0. So I had 4x equals 3. And then to get rid of the 4, you would divide, because the inverse operation of multiplication is division. So you would get x equals 3/4. So you can check that by putting 3/4 back in. And that should give you a true statement. So 4 times 3/4 would be 12/4 equals, and then you have 3 plus 7, and that does equal 10. So you know when you put it back in, it checked out. So this is your solution. It checked because you do have a true statement here. So why is today any different? Well, let's say that I gave you the equation 2 to some power equals 8. So this x is not being multiplied to the 2, it's 2 raised to the power of x. So you should know that. What could I raise 2 to get 8? So in your head, you should be able to know that x equals 3 in that situation. Because if I check it, 2 to the third would be 2 times 2 times 2. That would be 4 times 2, and that would be 8 equals 8. So it checked out. 3 did make it true, so that's your solution. So that one you can do in your head. Well, what about this one? 2 to the some power equals, and let's say 16. So 2 to what power should give you 16? You should be able to do that one in your head. And that should be x to the 4th. If you check it, 2 times 2 times 2 times 2 would be 4 times 4, which is 16. So it checks, so this is your solution. Now let's think about this. 2 to some power equals 7. Excuse me, not 7. Let's do 10. Now some people, when they're first doing this, they put 5 because they divide by 2. But once again, this is not 2 times x equals 10. This is 2 to the x equals 10. So there's somehow I have to get rid of this 2. Okay? Now, can you do this one in your head like you could this one and this one? No, because 2 to raise to some power has to give you 10, which is it's not as simple or as quote unquote clean as 3 and 4. So if you look at this, 2 to some power equals 8 and 2 to some power equals 16. Well, if this solution was 3 and this solution was 4, what does this solution have to be? Well, since 8 and 16 are here and 10 is somewhere in the middle of those, then my answer is going to be approximately 3 point something, 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 something. Okay, but how do I solve for that? All right, how do I solve for the 2? So what I'm going to show you today is how to get these answers. When I get back, I'm going to show you how to get them in the calculator as far as being able to check your answers. Okay, so today you're just going to learn the process of doing this. Okay, so we'll go ahead and do this other one. Do the 2x to the 10th. So you've never had to get rid of a base before. Again, this is different than this problem, because I can get rid of that 2 very easy, because the inverse of multiplication is division. But in this problem, I'm finding the inverse of a base. So here we go. The only thing you have to do here is this big base, we're going to call that a big base 2 because it has an exponent on it. So what you want to do in these problems is like this one where I got rid of the 7 first and got the 4x. I want a term that just has the x with it and then get everything off of that. So here's what you're going to do. To get rid of this big base, you have to do something called a log. And what you do is, if this is what you're solving for, circle it. You want to get rid of the 2. So this is how you're going to get rid of the 2. You're going to put a log, which is known as a logarithm, a log, and you're going to put a little 2, and then you're going to write what you have here. So I've not written that yet. I've just done log base 2. And that's what it's called, log base 2. And then you're going to write 2x equals. Now what you put on the left side, the log of 2, you also have to put over here. Just like everything else. If you do it to one side, you have to do it to the other. So I'm going to put log base 2 here, and then I'm going to bring the 10 down. So like over here on this example, I know I'm skipping around, but it should kind of make sense now. The 2 divided by 2 would go away because the 2 divided by 2 is 1. I have the same number on top and bottom. So here, what goes away is if I have a little 2 and a big 2 here, it goes away. So my answer is going to be x equals, because this cancels like this one did. And then my answer is going to be log base 2 of 10. Now why doesn't this cancel? Because 2 and 10 are not the same number. Okay, so that's your answer because x is by itself. Log is an actual operation. So just to show you, and once again I'll show you this more when I get back. But in your problem, I just want to show you that this is 3 point something. So there's a log key on your calculator. And to get this number, oh, sorry about that. To get this number, you would hit the log button and do 10 divided by log of 2. Hit enter, and there's your answer, 3.321, which is what we predicted up here. And these squiggly equals marks means it's not exactly that, but it's approximately that. Okay. So that's how you do that. Now this part I'm going to teach you when I get back. So what I want you to get today is just this in the box. All right, let's do another one. What if I had 4 to the x equals 7? So some power of x has to give me 7. So here's what I'm trying to get by itself. It's just a number in the variable, or just the exponent, so it's down to just the base and the exponent. So how do I get rid of this big 4? I put a little 4, and then I write 4 to the x. And then if I do it to this side, I must do it to this side. Now, if this little number and this big number are the same, that's going to cancel. I'm left with x equals log base 4 of 7. That's how you say that. And that's your answer. That's as far as you have to go. Okay. What if something looks like 5 to the x plus 1 equals 63? So this is essentially by itself. The x plus 1 looks a little bit more complicated than just the x. But the outside thing here is the 5. I have to get rid of this before I can deal with the plus 1. So how do you get rid of this big 5? You take the log of a little 5 and write 5x plus 1. So the thing with the x determines what log you put. Okay, so if I had log 5 here, I must do it to this side as well. So I have log base 5 of 63. So here, same operation on both sides. But this side's going to cancel out because this one and this one's the same. So I have x plus 1 equals log base 5 of 63. This is going to stay intact because 5 and 63 are not the same. But I do have to get x completely by itself, so I'm going to subtract 1. So I subtracted 1 from both sides. Now, this does not become 62. You have to leave it like this because that log is an operation. You have to do something with the 5 and the 63 and then subtract 1 from it. Okay, I'm going to show you one more, and then I want you to go to the next video and practice. So what if I had 7 times 4 to the 2x plus 3 equals 5. So you have 7 times 4 to the 2x plus 3. Now this is what I'm trying to get by itself. I'm trying to get x by itself, but it has a lot more stuff on it. So like your equations, you're going to kind of ignore this piece because it has the x with it and get rid of everything else. So the first thing you would do is subtract 3. Then you have to get rid of the 7 because it's attached to this piece, but I can't get to the 2x until I deal with the 4, and I can't get to the 4 until I deal with the 7. So I'm going to go ahead and divide the 7 off because it's 7 times this piece. So these 7's would cross out, and I would have 4 raised to the 2x equals 2 sevenths. Now I'm almost to where the first couple examples came from. This 4 is completely by itself. Again, I can't deal with the 2 until I get rid of the 4. How do I get rid of a 4? That's a base, so this is part of the exponent. So how do I get rid of this? I do log base of that number that matches there. Then I write that side because what I want those to do are cancel out. But if I put log of 4 on the left, I have to put log of 4 on the right, and then write 2 sevenths. This is going to cancel, and I have 2x equals log base 4 of 2 sevenths. Then to get x completely by itself, I divide by 2. And that's going to be it. That's your answer. Do not cross anything out. This is your answer. Okay. All right, so that is the introduction to logarithms. Go on to video 2.